Right then, so we're going to do exercise 54 of section 1.3 in Stewart's Calculus 7th edition Early Transcendentals. And it's a word problem, and I generally don't do these because they take time and a lot of explanation that I really don't feel like doing because it really just increases the time of my videos, and I don't feel like putting you through all that hassle. But I'm going to do this one because it's kind of quick. So, 54. A spherical balloon is being inflated and the radius of the balloon is increasing at a rate of 2 centimeters a second. A expressed the radius r of the balloon as a function of the time t in seconds. And part B says if v is the volume of the balloon as a function of the radius, find v of r and interpret it. So this is relatively easy if you think about it. You got a balloon, and I'm just, for simplicity's sake, going to assume that it's a perfect sphere. Okay, and it has a little radius right here. That's our balloon. So assuming that it is a perfect sphere, which it most likely isn't, its volume is going to be 4/3 pi r cubed, and that is the volume of a sphere. Alright, so the part A says express the radius r of the balloon as a function of the time t in seconds. So this is not too difficult. Let me get a good color. Oh, I just used that. Okay. A spherical balloon is being inflated and the radius of the balloon is increasing at a rate of 2 centimeters a second. So after 1 second, assuming the balloon has no volume, after 1 second its radius will be 2 centimeters. After 2 seconds its radius will be 4 centimeters, and after 3 seconds its radius will be 6 centimeters. Do you see where we're going here? I hope you do. So radius is equal to 2 times t, and t is our seconds. So after 1 second we have that the radius is 2 centimeters. After 2 seconds we have that the radius is 4 centimeters. 3 seconds, 6 centimeters, 4, 8 centimeters, etc. Alright, so that's part A that we just answered. And part B says if v is the volume of the balloon as a function of the radius, find v of r and interpret it. So here we have v of r, but you could also write this as what r is. So 4/3 pi times 2t cubed. Alright, so it says interpret this. There's not much really to interpret. As the radius increases, it gets cubed, and then it's multiplied by pi, and then it's multiplied by 4/3, and then you're given your volume, So, what we have here is volume in terms of time specifically of t seconds. So the volume will increase as time increases in this case. In this case here we have volume in terms of the radius, but we kind of made it a little more complicated by putting in the actual definition of radius in this case for the definition of volume, or for whatever volume is equal to. So this wasn't a very hard problem. You probably looked at it and thought, oh my gosh, a word problem with 2 parts, and it involves volume, but it wasn't that hard.